Hello and welcome to InnoGrid TV in association with Engerati. I'm now joined by Michael Walsh as the Vice President and Managing Director of Smart Wires Europe. Michael, first of all, welcome.
Thank you.
Thanks for making the time to be here. And you've got one of those company names that actually tells you what it is you're trying to do, but let me not try and have a go at explaining it. Smart Wires Europe, new technology applicable to the transmission grid, probably also further down the line to distribution. But tell us a little bit about, no one sets up a new company, brings new technology without trying to solve a problem. So if I can ask you very quickly, describe the technology and we'll go on to what the problem is and that you're trying to solve.
Yeah. Well, I might start with a very large view. We're dealing with a world that's changing around us really, really quickly. We're dealing with, people want to do an energy transition to deal with climate change. We've got to a situation where renewables are become so cost competitive and so local to users that it's changing the pattern of flows in our grid. We've also got a world where citizens are much more engaged in energy choices, both what their energy comes from, how it's generated, but also how it's delivered to them. And that's really where we've hit an issue, that we're trying to push this new source of energy through the existing grid that was planned for a completely different set of generation sources. And what we do in SmartWires is we help you use that existing grid that you already have to move sources around in different areas. And we've developed new technology that allows you to steer power flows on the grid so that you can meet the needs of your customers, let them take in new source of generation, but do it on your existing transmission or distribution network.
So how does that work? Is that part of, I was talking to someone else in this market where they were saying that, listen, we have not even begun looking at what semiconductors can do on the electric grid, and they were coming at it from a smart meter, volt-var, local regulation. They were like, there's so much we can do just by applying. Is it some of that trend that's being applied to your technology? I mean, how does it work? Just bring it to life a little bit for us.
Okay, well look, I think your previous guy hit it on the head. There's so much that we can do that we traditionally don't, and one of the problems in this network, in this industry, is we've built up expertise over nearly a century, and with that expertise comes conventional ways of thinking about the problem, about how power flows on the grid. And because of that, a lot of companies, they're maybe not used to thinking of new technology or new ways of doing it. So our one in particular, they're devices that you can put on your transmission or your distribution lines, and they essentially act like a little lever that you can just turn up, turn down to increase or decrease the power flow on the line. And that previously wasn't possible. Previously, you built your generation and the power flowed wherever it wanted. It was like water flowing down a hill. It would flow down the fastest way down the hill, it would flow there.
It's basically what it was about optimizing the transmission through the conductor and then all those other conversations about building superconductors and things like that.
You designed your grid based on, you knew you were putting a large coal-fired plant. It's going to sit there for 40 years. It's going to feed this city and this city. And you designed one pipe this side, one pipe this side, and you built them the right size for a flow. You knew it might go up 1-2% a year, but that's all it's going to change. And now we've got these huge changes, and we're seeing some of the pipes are getting overloaded. Others have huge amounts of spare capacity, but the power is still trying to flow down the overloaded pipes. And what that means now is that the grid operators say to a wind farm, to a solar park, to a new data center, you'll have to wait until I reinforce this grid before you can connect. With SmartWires, what we can do is we can take some of the power flow that's going through the overloaded paths, push it back off that, and down a different path where there's spare capacity available. And what that means is that you can now connect your new generation, meet the needs of your customers, and you can do it in weeks or months instead of waiting years.
So let me ask a simple question in that analogy. So I have got a power plant, forget what fuel source it is, it's a power plant, and it's connected to a transmission line which is going from here to there. How is your technology going to deviate the power when it's a straight connection and there's nothing to deviate it to? I mean, how does that work?
Yeah. So the amount of power that flows, power is essentially lazy. It follows the path of least resistance from where it's generated to where it's consumed. And what our technology does is it allows you to vary what that path is. So if you have, say, two paths and 60% is flowing here, 40% here, we can make this path less attractive. In electrical terms, we can change the impedance of it. And by doing that, it makes this path less attractive to electricity. So now instead of having a 60-40 split, you can make it a 50-50 split, you can make it a 65-35. You can make it flow whatever way you want so that you use the capacity that's available to you in the most efficient manner. And I wanted to share one number. It's something a few people talked about yesterday, was how much of our capacity we actually use. And in some grids, we have about 80% spare capacity overall on our networks. And this is at a time when the grid has been seen as a bottleneck to new development, when renewable generation has been held up, when changes to empowerment of consumers have been held up because of grid issues. But yet we've all this spare capacity that we're not using. And what our technology does, it allows you to bring that to life and use that to meet the needs of your customers.
So what I'm hearing is it makes complete economic sense, because you don't have to build yet another whacking great big transmission line. What you need to do is optimize the current asset, and as you said, there's 80% capacity in there, but you need to do it. We need to react quickly. So how quickly, in theory, can your technology be brought to bear? Because building another transmission line, as we all know, you're talking years.
Yeah.
And your stuff, what sort of timescale are we talking about?
So you're talking, weeks or months. It's
Right.
that order of time frame from, when we decide we want to do something to having the deployment. But the other thing about our technology is it's redeployable. So by that I mean you can put it in one place on your grid, and if you find in a year's time that problem has gone away and you have a different problem, you can pack the technology on the back of a truck, move it somewhere else and redeploy it. So that means that you're now not making decisions where you have to try and predict the future 40 years in advance. And let's be honest, who's good at doing that? You can see, what problems have I got coming in the next 6 months, next 2 years? Deploy a solution that solves those problems and then move it. Increase it. If the problem gets worse, you can add to it. You don't have to get it right first time. You can build on extra modules to make it a bigger solution. You can make it a smaller solution if the problem is not getting as bad or if it doesn't materialize. And that gives grid operators huge amount of power to be responsive. They can deal with uncertainty in much more effective manner than, as you say, like trying to plan a transmission line now that is not going to be there for 10 years. Like, I ask you, who can tell you what the power system is going to look like in 10 years' time, let alone 40, which is still in the asset life?
So let's touch on another topic. There are clearly innovations out there where people have looked at this problem, maybe from outside of the industry, and gone, "Hey, I'm a semiconductor designer," and we've seen it in our own world. When you used to get a new mobile phone, you used to get a whacking great big brick that was the charging unit, and now it's a tiny little USB device driven by semiconductors. We're seeing it there. How easy, and there's a lot of talk here about innovation and adopting new technologies and bringing in new thinking, how easy is this market really to get into?
So, an excellent question. And look, let me start I think in 10 years' time, all of these technologies are going to be up and running, and they're going to be delivering huge value for consumers, and the grid that we're going to be operating will be unrecognizable from what we have today. It's going to be a dynamic creation that allows you to meet the needs of your consumers. But the big question is, and you hit it, how long will it take us to get there? The technology is ready today. It's there, not just our technology, but you mentioned there's lots of exciting technologies out there. But the problem is we're in an industry where the habits, the processes, the decision making has grown up over a century. And we're still thinking about these decisions the way we did in 1950. We're still planning, taking 3-4 years to make a planning or an investment decision on a need that is there today. Might be gone in 3 years' time by the time we've made a decision. And then, as you say, another 7 years to make the investment. And when you talk to grid companies, they very often talk about innovation and openness to it, but it's very, very slow process to get from that to where they actually look at changing the decision-making process to make decisions faster, to deal with the problems that they're seeing today and deal with them effectively and giving themselves optionality.
And it's one of the things that you were telling me about, because again, in a previous life, this hasn't been the only job you've had. You've got very real experience about how those decisions happen. And you were saying to me that actually the decision-making chain is so long and so complex, and every person along the way has some sort of right of veto. So how does, I know we're going a bit away from your tech and your technology, but in your view, how does this market need to change and make itself open for innovation? Because the other thing that's going to happen, if it does not, it'll either get bypassed because new companies with new tech, with innovative solutions, want to get out there. They don't want to sit in endless meetings talking about, oh yeah, we might do something in 5 years' time, right?
Yeah, absolutely.
You need it now. So what does this market need to do to change it?
Yeah, so I think that's a really great question that a lot of the leaders of transmission companies need to think about. And you mentioned my previous company. My previous company, I'd say, is a case study in best practice. But I'd let you talk to them directly to talk you through what they're doing. I think what needs to change, you mentioned 100 people. What happens very often, you get one or two people, be it an innovation director, an operations director, a chief executive, that sees, I need to change, I need to innovate, I need to use this new technology. But then it gets caught in this organizational treacle where everyone along the way, from every engineer, every technology adopter, every purchasing manager, every finance, every legal, they all have a question and deal to answer. And all these things happen in sequence, and it takes something that, in theory, an innovation idea that could be done in maybe 6 weeks takes 6 months. And by the time you've done that, I'll give you one example of a project we looked at, and it's the increase cross-border flows between two European countries. This project has the possibility to save €20 million for European consumers in just 2 years, but only if it gets deployed in about 1 year's time. Now, if it takes a year to make the decision, and then a year to actually roll it out and make it happen, you've cost consumers 10 million by just sitting around waiting to make the decision. And that sort of thing is endemic in this industry. The decision-making timeframes are consistent with assets that take 10 years to build, not with new technology that you can deploy in 6 months, in 3 months, in a couple of weeks.
I mean, a case in point, I do a lot of commentating about what's happening in the African energy market, and they are actioning and building, grid-scale solar farms in 6 months.
Yeah.
Right? So
Absolutely.
that is how quickly this stuff can, in theory,
it can be done.
Get done. So let's bring it to life a little bit as we come to the end of our time here. You have got a couple of projects up and running. So, again, you know what this industry is like. It likes a lot of validation. So let's validate the technology for them. Tell us about those projects and what sort of cost benefit they're seeing.
So some of the most exciting projects that we have in the tank at the moment, two we're looking at, they're very small projects in terms of what our solution looks like, but they're releasing huge amounts of renewable capacity, one for about 200 megawatts, one for nearly 1,000 megawatts. And that's essentially by going into a critical pinch point in the grid that's the limiting factor, pushing power away from that and allowing others to connect. One number I just want to maybe share that I heard earlier in the conference was the sort of projections for how much we're going to spend on networks in Europe in the coming 10, 15, 20 years. And people were talking about numbers from 150 billion to 400 billion. And you mentioned then the conservatism of the industry. So you go in with a new technology project that's single-digit millions, and it gets this whole amount of scrutiny, but yet people are spending billions without asking themselves, do I need to do this? I mentioned a quote yesterday, half of all the money I spend on advertising is wasted. The problem is I just don't know which half. It was John Wanamaker about 100 years ago. And I think we're at a similar point in electricity at the moment. And I think the focus should be not on, could I save 100,000 to 200,000 on my innovation pilots, but could I be saving 10 billion on the infrastructure spend? And me, it's a simple answer.
And that is a perfect place to leave this interview. Thank you very much for watching InnoGrid TV in association with Engerati, and For those of you who are on our network, there's loads of information about this new technology that's out there. Do go and check it out. Thanks again for watching.